Welcome to Kigali-Engineers-College.
Welcome to Kigali-Engineers-College, especially today's session is about the charging system. Here we have the tools, materials, and this component we are using in this session. So, the first one, equipment, it is the multimeter. This is the reed. Those are reeds of multimeter, spanners, plier, and screwdriver. Those are tools, materials. We have here battery, and also this is component which called the alternator. Alternator, it is used in the vehicle to charge the battery while the engine it is running. So we are going to see the circuit of charging systems, and we will see the special component of alternator used in order to produce the voltage to charge the battery and how it works. And after we go to see and measure the voltage on the alternator on the panel. So let's start drawing the circuit of the charging system. Charging system circuit with 9 diodes. So the first one, let's start on the drawing the symbols that represent the parts of alternator. The first one, let's start on the rotor. Rotor, it is the moving part of the alternator. So it have the strip and brushes, and also have the winding. Excitation winding comes here. So ground, and this is we see where it's go. So let's go on the starter. It's winding. So Y connection. So let's this is the starter, and let's draw the symbol of starter, alternator starter. So let's draw the power diode, and also here we have a power diode, and also we will draw the excitation diode. This symbol represents the diode. And also we will see where this wire go. So let's draw the excitation diode. Those are excitation diode. Let's connect to those power diodes, and the other wire connect to the excitation diode. Let's connect this starter winding to power diode. First one going to the first one, connect it. The second one going and connect to this one, and third one connect. So we are going to draw the electronic alternator regulator. So the first one, to have the resistor. So here we have Zener diode, and also here we have transistor. Here we have a resistor. And also here have another transistor. Here we have diode, and here we have out, citation. Here we have a ground. So the first one is here we must have a positive. So here we must have a positive, and also here we must have a negative. So we enter, and here we out. And also here let's have a battery, a symbol of battery. This is ground, and also out. This is positive, negative. So here we have the power diode, which will take the cable going to the battery directly. It is where the output voltage going to charge the battery. And also here we have ignition switch, which is take the current from this excitation. And also here we have the charging indicator lamp going up to this terminal. So this is negative, and also this wire is for excitation, coming and connected to here to the rotor in order to make excitation. So this is negative, and so this is the rotor with the brushes and other thing. This is tata, and also power diode. This is excitation diode, and also this is ignition switch. You make sure you make a fuse, protect our circuit, battery, charging indicator down. We see that our rotor, it will be magnetized because we cross the ignition switch. So when you start the engine, it means that it is connected to this rotor. So it's turn, it's rotate with it, and does rotation, it creates magnetic field, and those phenomena cause the creation of the voltage in this starter. So the voltage go through this one, pass through this first diode. Because it's positive, it's cross the diode and also pass through here, going to charge the battery. And also if it goes on this wire, goes through here, pass here, and also go here out to going to charge the battery. And also it's same as on the third one, pass here, going to charge the battery. So on excitation, and also the current, it does not pass through here only, it passes through this diode and going here, and it passes through here, going here, and make a self-excitation of this rotor. So when the battery it's a full, this Zener diode, according to the manufacturer, it will open. Maybe it's just the maximum, it is 15 voltage or 14.5 or above. It's between here voltage, so it's open and allow this positive and this transistor allow the current to pass through here, and here it will be the positive. It means that this transistor, it cut off the passage of this current that pass through here and going to the excitation. It means that there is no excitation in the rotor. That will cause there is no creation of magnetic field on here. That causes the creation of the voltage in the starter of alternator. It means that there is no voltage or current. There is no current pass through on those diodes. It means that the battery is full. If it return at low voltage, then this set the manufacturer on this Zener diode, it will return back. Here it will be there is no voltage, and also here they will return the negative. There is no voltage, and also work as the first working principle we say. So here we have the alternator. We have, this is the pulley as we draw here, its symbol, and fan. This is the rotor on the panel where there is a full charging system component, and we just operate it and measure the voltage that the alternator produces. So let's go on the panel to see the practical. So let's see the practical rig to measure the voltage of alternator and see the wire we said where it's located and how to measure it. So let's start here. Let's measure the voltage of the battery in order to see if our charging system works properly. So we see that it have the 12 SAT8 voltage. SAT8 voltage. So we see this wire, it's for the wire of ignition, as you see on the drawing we draw on the board. It's wire from the battery positive through the ignition, but we bypass. So, and this one, it is the wire from the charging voltage from the power diode to the battery in order to charge it. It is where we receive the DC voltage, which is converted by the power diode from the actually the alternator to produce the alternative current, and the power diode convert into DC current. So through power diode, this is the cable that come to the power diode to charge the battery. So let's see if the voltage reach on those wire, and this is the alternator. So we will remove it by the electric motor behind here. Come and see it. You see, this is electrical motor that is used to rotate this alternator. So let's see if the voltage reach. We see that this red wire, big red wire, it is for the charging the battery. It comes from the power diode. So we see the voltage reach here. We see that it is the 12. It means the ignition is the on position. And also, if we measure here on this wire for exciting path through the electronic alternator voltage regulator through until to the ground. So we see the voltage reach here. You see, this is the neutral, and we see the voltage reach here. So there is no charging. This is the pre-excitation phase. The another one, if you turn in the start, you reach on the excitation where the alternator produces the current to excite itself. So the another one, it is the charging phase. After the excitation itself, it will charge the battery. So we have here no engine, but we will use that electric motor I show you to rotate this alternator. Now it means that the rotor inside this alternator it is magnetized. But if there is no rotary motion of that rotor, there is no production of the voltage. If we rotate the rotor, that flux of magnetic to the starter of this alternator, it will cause the induction of the voltage, AC voltage, pass through the winding of the starter, alternator starter, as we show you in the diagram, pass through the power diode, then out the power diode, it will out with DC current. So it means dielectric current. So we are just going to turn our alternator on. So come and see how the voltage increase. First let's turn off. So we see that the voltage it is on 12.46. Let's turn on. Let's turn on the electric motor. You just turn on the maximum. Turn on the maximum. We see that it reach on the 30 voltage. You see the voltage increase. So we see that's how it means that our alternator it is working properly, because if it does not work properly, the voltage reduce instead of increasing, because there is a rod like this lamp and the others that control the voltage. It means that it will reduce instead of increasing. So this alternator is good. I hope that you get the special thing in this session, because you will measure it and you will diagnose it according to those principles we learn of charging system operation. Before we diagnose some system, you will know the first of all its operation properly. So if you are going to diagnose, you will start from the fuse. You measure if your alternator works properly. You will use those skills we provide. So for more video and more skills, don't forget to subscribe, comment these essential things, and share to your friends. So thank you so much. We will meet in the next session.